Our group analyzed perchloroethylene, or PCE, which is a colorless, non-flammable liquid with a sweet or ether-like odor. It is a volatile organic compound that primarily is used in dry cleaning and for degreasing of metals. Other uses of this include in aerosol products, solvent soaps, painting inks, adhesives, sealants, paint removers, wood cleaners, and shoe polish. The easiest way to be exposed to PCE is by dry cleaning your clothes. This releases small amounts into the air, or if you live near laundromats that contain cleaning machines. You can also get exposed to it by using many of the products that contain PCE, and there are low levels of exposure in air and water from the industrial releases. Short-term exposure to PCE can cause damage to the central nervous system, unconsciousness, and death. Long-term exposure can also cause damage to the central nervous system, the liver, kidneys, cause respiratory failure, memory loss, and dry, cracked skin, as well as damage to fetuses. People who have heart disease, liver disease, kidney disease, and lung disease are also more susceptible to the effects of PCE.
The main sources in the environment today of PCE come from the degreasing and dry cleaning industries. PCE started to be used in the dry cleaning industry around the 1930s, and at that time it was vented from local stores, which contributed significantly to local air pollution. Today, however, the main concern with PCE is as a soil and groundwater contaminant, where it behaves as a dense, non-aqueous phase liquid, or a DNAPL. The density of PCE causes the contaminant plume to reside in or around the matrix of the lower confining layer of the aquifer, where it releases contaminants into the drinking water. When this poses a safety risk to the public in the drinking water, the best method is in situ bioremediation.
A level 1 fugacity model displays that a 5,000-gallon spill of PCE into the environment would almost entirely vaporize. A staggering 99.5% of the mass would enter the air. This, of course, is dependent on how PCE is introduced into the system. If the spill occurred underground, for example, the PCE would clearly not vaporize, but instead sink to the bottom of the water table, given that its specific gravity is much larger than that of water. The model helps show that since PCE is highly volatile and highly likely to enter the atmosphere, that the most effective remediation technique would likely be some form of air stripping at the pumped well which contains the contaminant.